Okay, let's compare and contrast geometric and arithmetic sequences. This went with 10.3a notes. So remember that geometric or exponential growth or decay is expressed as multiplication, including words that include doubling or halving. So if you see something that says, the bacteria is doubling every hour, that is represented by a geometric sequence. So those are some key words. The formula for geometric sequence is a reminder here. A sub n equals a1 times r to the n minus 1, where a sub 1 is your starting amount and r is your rate. And then we have arithmetic, which is in a linear equation. So if we have an arithmetic situation anytime we have a constant rate of change, like you're earning $5 every hour. So every hour your paycheck is increasing by $5. So a constant rate of change. The formula for an arithmetic series is given here as a reminder. A sub n equals dn plus a sub 0, where d is your common difference, what you're adding or subtracting every time, and a sub 0 is your term before the first term. So that's a little review and some key words that we're going to be looking for when comparing the two situations. So let's look at an example. So we want to decide whether or not it represents arithmetic or geometric, and then write the equation that goes with it. So a library has 8,000 books, and it's adding 500 books more each year. So a keyword here is that it's adding 500 each year. And so it tells me that it would be arithmetic because that's going to be a constant rate of change. Every year we have the same amount being added. So I can find my equation for this formula if I find my key pieces. So remember that the formula is dn plus a sub 0. So you're changing by 500 each year, so it's going to be 500n plus, if I had 8,000 books, that's my a sub 1 term. So if I subtract 500 to get a sub 0, it would be 7,500 books in the year before that first year. A gym's customers must pay $60 for a membership plus $2 each time they use the gym. That again is arithmetic because we're paying $2 each time they use the gym. That's a constant rate of change. Every time you go, you pay $2. It's not $2 and then $4 and then $8. It's just $2 every time. So we can write the formula as dn. So, change back to a pen. A sub n is dn plus a sub 0. So $2 every time you go, and then if it started at $60, subtract 2, it'd be $58 before you go. So let's say that n equals 1 is your initial cost. Then if you plugged in 1 for your first time that you're there, you'll see that you're paying $60. So the very first time you're there, you pay the membership $60, your initial cost. Example C, a bank account starts with $10, and then every month the amount in the money in the account is tripled. Wouldn't that be nice? So since the amount is tripled, that tells me that it will be geometric. The amount in the account is going to increase 3 times every time. So it's geometric, where my original starting amount or my first term is 10. So this one is a sub 1 times r to the n minus 1. And if it's being tripled every time, r will be 3. So my formula will be 10 times 3 to the n minus 1. So if you wanted to check your formula, remember your starting value then, when n equals 1, that's how much money that you have when you first open the account. It should be $10. So if you plug in n equals 1, you're going to get 10 times 3 to the 0 power. Remember, 3 to the 0 power is 1, so you get $10. So our formula works. Your starting value is 10. All right, let's compare a situation here. And this is to see which situation would be better, arithmetic or geometric, which one's growing slower, which one's growing faster. So Mrs. Johnson is growing bacteria in the lab. She has 2 cultures that are growing as follows. Culture 1, the culture began with 10 bacteria, and each hour, H, the culture increased by 2. In culture 2, the culture began with 5 bacteria, and each hour, H, the culture doubles. So we have 2 situations. The one that is increasing by 2 is an arithmetic series. So this one is arithmetic, where we can model it with the arithmetic series equation. In culture 2, the culture is doubling each time. So this is a geometric series where our rate is being increased by 2 every time. So our R is 2. So we can write the equations for each one. Here we're increasing by 2 each time, so our D is 2. And if we start with 10, the term before that would have been 12. Or wait, 8. It would have been 8 because we need to go back the other way. So our A sub 0 would be 8. And then for culture 2, A sub n, A sub 1 is we start with 5 bacteria and we are doubling it, so our R is 2. So it'd be 5 times 2 to the n minus 1. So those are our equations that represent each culture. Culture 1 and culture 2. Now, what type of function represents each culture? Oh, we talked about that. So this one's arithmetic, this one's geometric, and then we have the equations. How many bacteria will there be in each culture after 2 hours, and how many bacteria will there be in each culture after 5 hours? So we have culture 1, and we have culture 2. And they want to know how many bacteria will be in the cultures after 2 hours, and then how many will be in there after 5 hours. So they want to know when n equals 2 and when n equals 5, compare the two. So in culture 1, if I plug in 5 for n, we're going to have 2 times 5 plus 8. So that's going to be 10 plus 8. We're going to have 18 bacteria after 2 hours in culture 1. After 5 hours in culture 1, I'm going to plug in 5. Oh, whoops, I think I did that wrong. Sorry. 2 hours, I'm going to plug in 2. So we're going to have 4 plus 8. We're going to have 12 bacteria in that one. It's plugging in 5. We're going to have 10 plus 8. After 5 hours, we'll have 18 bacteria. So after 2 hours, we have 12. After 5 hours, we have 18 in culture 1. In culture 2, we have plug in 2 for n. We're going to have 5 times 2 to the 2 minus 1, or 5 times 2 to the first. So 5 times 2 is, we'll have 10 bacteria after 2 hours in culture 2. After 5 hours, we're going to have 5 times 2 to the 5 minus 1, 5 times 2 to the 4th, be 5 times 16, and 16 times 5 will be 80. And so we can see that culture 2, the geometric series, and this one's the arithmetic, is growing much faster. After 2 hours, culture 1 has more bacteria. But after 5 hours, culture 2 has extremely more bacteria. So a geometric series will increase much faster than an arithmetic series. In the beginning, the arithmetic series might be a little bit more, but even 5 terms later, the geometric one is going to be much greater. So there's way more bacteria when it doubles. And that's usually how bacteria works, unfortunately. Okay, that's all I have, I guess, for this video. So comparing and then being able to look at 2 different situations and talk about it. Thanks for watching.